Hello learners, welcome to session 4 of Unit 1 in the course Introduction to Abstract Algebra. In the previous lesson, we learned how to find inverse fugitive mapping. In this section, you will learn more about binary operations. I am Munkaila Dasmani and I'm your course instructor. So session 4, we are looking at binary operations. By the end of this session, you should be able to explain binary operations. You should be able to give at least 4 examples of binary operations. You should be able to give at least 2 examples of non-binary operations and determine if a given set is closed with respect to a binary operation. What is a binary operation? A binary operation is simply a rule for combining 2 objects of a given type to obtain another object of the same type. Good. So mathematically, let's look at definition 6. A binary operation on a set S is a mapping star that assigns to each ordered pair of elements of S a uniquely determined element of S. That is, the star, which is the operation, is such that S cross X goes to S, and it's a mapping. So that's the rule. And the rule says that X cross X objects of the same type, that's S cross X, and it goes into another object of the same type, that is S, and that is mapping. So the star here is the operation symbol we are using. Somebody can use circle, maybe circle with dot inside, circle with shaded, and then somebody can also use open circle, somebody can use triangle down, triangle up. We have a number of symbols that we can use to represent a binary operation, but in this course we will use star mostly, and we will also use few of the other symbols that we use to represent binary operations. Let's look at examples here under the binary operations. So let's see example 1. Let me write this. Example 1. Take my pen. Example 1. Let's say that A and B be a member of R, and you know that R is the Israel mean a real number. Then what can you say? You can say that A star B is equals to A plus B. So that's the rule. A star B equals A plus B. And what can you say about A plus B? You can say that the A plus B is also a member of R. And that is, one can say that addition is a binary operation under the set of numbers. So when I choose any 3 numbers, the 2 numbers, let's say 3, I'm choosing it 2 numbers, 3 and then 4, they are all members of R. So when I put into the operation, so 4, what do I get? 3 plus 4, and what's the answer? 7, and 7 is a member of R. So here you can see that addition is a binary operation under the set of numbers. Let's look at number 2. So number 2, if we say, let's say X plus A plus B, let me use A plus B, be a member of Z. You know the Z is the integer or the set of integers. So if I say that A star B equals AB, then what will be the result of AB? So we can see that AB are also the members of Z. Once AB are members of Z, then one can conclude that multiplication is a binary operation under the set of integers. So choose any 2 integers and see. Let's say 1, 2. So you can say that 1 times 2 is an integer. Let me use minus 1 and 3, or minus 5 and 5, minus 5 and 4, any of them. If I use minus 5 and 2, minus 5 times 2, I get minus 10, and minus 10 is an integer, and minus 2 and also 5, they are all integers. And that is to say that multiplication is a binary operation on the set of integers. Let's also define the set. Let's say that number 3, A star B equals, let me use the mass, okay, mass, and then the curly bracket, A comma B, A star B equals max A comma B. So that's the largest of A and B, the maximum or the largest of A and B. So what can we say? Then the star is a binary operation. You can see the star is a binary operation because any number I choose, I can definitely get the maximum of that number. Okay, and that is binary operation, examples of binary operation. You can find more of examples of binary operation in your course material. You can find more. Thank you. Closure property. What's closure property? As we mentioned earlier. Now, this closure property is very, very interesting. Now, let's say that a binary operation star, I mentioned the star earlier that we'll be dealing with it match. Binary operation star is said to be closed on a set S, set S. If and only if, so given the condition, if and only if, whenever we have X be a member of the S and Y be a member of the S, then X operation Y is also a member of X. So once this condition satisfied, then we can say that the operation star is closed under the set X. For example, addition and multiplication are binary operations on the set Z of integers. So I write like this: addition and multiplication are closed under Z, are closed under Z, are closed in Z, the integer Z. So when taking it, two numbers, you multiply them together. Two numbers that are integers, you multiply, the result is actually an integer. Similarly, when you take two numbers that are integers, you add, the result is an integer. What about division? What can you say about division? So when I take two numbers and I divide, do I get the same type of number? For instance, when I pick 3 and 2, let's say 3 divided by 2, 1.5, that is not actually a member of Z. So in that instance, we can say that division is not closed, it's not closed under Z, it's not closed under Z. Okay, thank you for listening. Next we are looking at multiplication tables or K-less tables. Multiplication table or K-less table. As I made mention, the cross product to a binary operation on a final set, that's a set with a limited number of elements, is often displayed in a table called a multiplication table or K-less table. So the following is the example that illustrates that, and that is, we have the star there and then we have the condition. And the conditions is that we have star says that A plus A goes to A, A plus A goes to A, elements of the same type goes to elements of the same type, where A is the members of A, B, C, and D. So now let's look at the table. To calculate the value of, let's say, A, B, how do you find the value of A, B in the table? For instance, if I want to find A star B, what do I get? You can see that A star B is actually B. How do you do that? So you can find the answers easily. But first, locate the first value in the first column and second value in the top row. and then when they meet, then you can say that this is the value. So somebody can also find, let's say, C star D. C star D. What can we see? This is my C star D, and that is B. So you can actually find a number of them. So let's look at the next. Now, example 19, construct the multiplication table for addition modulo 5. Denoted X. So addition modulo 5. So this is how it's being denoted by this. So guys, now you remember modulo. When you talk about modulo, there's something that should come into your mind, the remainder theorem. So you can see that you're dealing with modulo 5, and then when I add every number here, I get the same thing. But let me look at this. 4 plus 1, I get 5, but it turned out to be 0 because of the modulo 5. Don't forget the remainder theorem in that order. Okay, now let's use the table to try to answer very few questions. Under this table, if I ask you to find, let's say, 3 operation 4, what do you get? 3 operation 4, you come to your 3 here, operation 4, you can see it is here, and the answer is 2. Likewise, I can ask you to perform some small calculations. For instance, when I say find 2 operation, let's say 3 operation 4, and in this case there's a bracket there, so don't forget about your board math. Bracket first, so I can get 2 operation, and there is modulo 5 operation, and then 3 operation 4, I get 2, and 2 operation 2 operation 2 is 4, and the answer equals to 4. So you can use the table to answer a number of questions. Great. So example 20, I leave for you, it's in your course material, but let's see small. A binary operation star is defined on the set R as A star B equals A plus B, and then we have plus 2AB plus 2AB. Okay, so we do one, then you do the rest. The first one says that we should find A. You should find 2 operation 3, 2 operation 3, and then operation 5. So here you can see there is sum in brackets. So board math, you do bracket first. So we start by 2 operation 3, and that will give you 2 plus 3. Wherever you see 2, you see A, put your 2 there. Wherever you see your B, put your 3 there. So plus 2, and then 2 times 3. What do I get? When you do this computation very well, you get 17. Once you get your 17, then therefore 2 operation 3 operation 5 is now equals to 17 operation 5, because 2 operation 3 is now 17. Now you also put this into the operation or the rule, and the rule is A, so this is equals to A, which is 17, plus B, which is 5, plus 2, multiplied by A times B. So A is now 17 times B. So you can actually write dots. Dots is same as the product. You simplify this very well, and then you get 192. Great. So in this section, we've looked at binary operations with examples, and then we've also looked at the closure property.